Hello, little algebrainiacs. Welcome to the Johnson Kendro Video Hour.
But it is not an hour.
Yeah, ours is yours, and yours is ours. But here we go. All right, solving radical equations. These are kind of fun, but you got to be careful. Radical equation is when there is a variable under the radical or there is a fractional exponent because that acts like a radical.
Can I say something?
You can.
Okay, sometimes, myself included, get lazy and I start writing it like this.
Oh.
So really be careful knowing what's under the radical and what's not.
Okay, that's a good
Don't be like
good
me.
thing. Mathematicians are lazy, but they're also detail oriented, so you got to be careful. Okay, so we're going to treat this a lot like a real equation. There's some hints over to the right side. The first one says isolate the radical, so we got to get that little beaster alone. Then number 2 says scare both sides.
I really like that font.
I know it took me a while to find it, but what I mean by that is to square both sides to get rid of the radical, but I say scare, so you check the answers because there might be a phantom answer, and that's scary because sometimes when you square both sides, it brings in an extraneous root, which means it doesn't really work, so you can't include it in your answers. All right, so let's first of all isolate the radical. Get that alone. We're going to get rid of this, minus 3. So I have 2x minus 3 equals 5. Now I want to scare both sides. So I'm going to square the radical, and I get 2x minus 3 because the radical and the square just cancel out. Squaring the 20 or 5, I get 25. Now it's a very lovely equation that you can solve all by yourself. So x equals 14. Now when you scare both sides, you really should check your answer. So over here, I'm going to write the exact equation. You got to start with the original equation. So 2 times 14 plus, oh, I better extend that.
Minus 3.
Oh, minus 3, bummer. 14 minus, let's see, minus 3 equals 8. All right. So 3 plus 28 minus 3 equals 8. 28 minus 3 is 25, so the square root of 25 is 5. So 3 plus 5 equals 8. So no phantom on that problem. All right, let's try another one. This one has an exponent, but it's in a fraction, so that kind of acts like a radical. So we're going to still do the same thing. We're going to isolate the parentheses. So I'm going to divide by 3 both sides.
I can't distribute that thing?
No, then you'll get messy because this 2/3 only goes to the parentheses.
Oh, I see.
So you got to be careful. Get rid of it first. So x plus 1 equals 4. Raise that to the 2/3. All right, so now I'm going to raise both sides, here it is, to the reciprocal of the power. To get rid of a power, you raise it to its reciprocal, so 3/2. So those end up canceling. I get x plus 1, and then over here, I'm going to take the square root first, that's 2, and then 2 to the 3rd is 8. So x plus 1 equals 8. All right, it says solve as normal. If the original exponent has an even numerator, the original one,
or if the one that you did was an even denominator.
Even denominator, yes,
yeah.
Over there.
Where your little
arrow is. Okay, so I need to use the plus or minus, so I have to put in a plus or minus 8. Let me rewrite that. X plus 1 equals plus or minus 8. Okay, then you have to subtract 1 from both sides. So x equals, you have positive 8 minus 1 or negative 8 minus 1.
And then that's tricky. I would think it would just be plus and minus 7. So you got to do your plus and minus before you get the x alone.
Right.
Got it.
Yep. So then you try the 7 and the negative 9 and make sure they work. All right, but for time's sake, we're not going to check them. They do both work if you put them back into this equation. So you make sure that you check them when you do your work. But we don't want to make the video longer than an hour. All right, here's the next one.
Una hora.
Una hora.
All right. Okay, this is a little scary because there's a root and an exponent. So what we're going to do is start by rewriting it as a fractional exponent.
All right.
So remember that the roots are on trees.
All right, roots are on the bottom.
So roots will be on the bottom. So this will be x plus 1 to the 3/5 power equals 25.
And now it's just like the other problem we just did.
Whoops, we just got a typo in our notes here. Please go back and add this +1 on to there. We forgot to type that in when we were doing this. So I'm going to start over. I'm still going to do the first step, rewrite using a fractional exponent. Oops. So that means it's not going to be a fifth root anymore. This will be an x plus 1, and then 3/5 power, the plus 1's on the outside, equals 25. I still want to isolate. To do that, the first thing I'm going to do is subtract 1. That will leave this stuff the same. The other side is just 24. Now divide by 3. X plus 1 to the 3/5. That's going to give us an 8 over there. And then I want to get rid of the power, and I'm going to do that by raising it to the reciprocal, which is going to be 5/3. Do I need a plus and minus?
Well, does the original have an even numerator? No, neither of them are either even, so we just solve as normal.
Yeah, it would be like a cube root. So cube root of 8 is 2, and then we're raising it to the 5th. We end up with 32. And I really didn't need those parentheses. Next step would be to subtract 1 on both sides, and we get 31 for our answer. What happened there?
All right.
31. I do need to check.
Okay.
All right, I'm just going to check real quick. I'm going to see if 3, I'm going back to the original problem, 31 plus 1 underneath there, 2 to the 3rd plus 1 equals 25. 31 plus 1 is 32. I'm going to do the root first so it becomes smaller, and then cube it. 5th root of 32 is 2. 2 to the 3rd is 8. So now I've got 3 times 8 plus 1.
That looks like 25 to
Is
me.
it 25? Yes, I think so.
Woohoo! All right, check it out. All right, try this one, but be careful.
I'm scared.
Oh, I better use Brad. Okay, I'm going to isolate the radical, so I'm going to add 5 to both sides. So I have square root of x plus 7 equals x plus 5. All right, now, square both sides. That's very important. You don't square each piece, so it's not x squared and 25 on the right. It's squaring the sides, so you have to do like a FOIL problem. So squaring the left is the easy part because the radical cancels with the square. Over here, I have to square it like this. So I get x squared, and then 5x, and then 5x, and then 25.
Wow.
Yeah, so I get x squared plus 10x plus 25. Now, we need to move everything over to the right. This
Now,
looks like
why did you choose to do that here? Because it's x squared?
to move everything to the right?
Yeah.
Yeah, because this is a quadratic, I noticed, with the next squared. And we had all last chapter was quadratics. So I want to set this equal to 0. I'm going to subtract x and subtract 7. So I get x squared plus 9x plus 18. And then...
I'm going to make you some space over here.
Thank you. So now, do you remember how to solve this kind of stuff?
Well, we talked about lots of stuff. There's like factoring, there's quadratic formula.
Let's try factoring. It's always the
Fast.
fastest way. So that x squared breaks into x and x. 18 is either 9 and 2, 6 and 3, 18 and 1. It has to equal a 9, so I'm going to choose that. Everything's plus, so I'm going to make both of them plus. Since it's equal to 0, x has to be either -6 or -3.
And you got that by setting those equal to 0.
Right.
Okay, this is when it's really important to check
Correct.
the phantoms.
Okay, the phantom. We scared both sides, so you have to check. So I'm going to put -6 back in here. So I get -6 plus 7 minus 5 equals -6. Let's see if this comes out true. So So I square root of 1 minus 5 equals negative 6. 1 minus 5?
No.
Oh boy, that one doesn't work, so we throw that one out. It's a
called
phantom answer.
Yeah, extraneous solution.
Fancy name, yeah. We better try the 3. So I put a negative 3 in there, plus 7.
That's
minus
4.
5 equals negative 3. So 4, square root of 4 is 2. 2 minus 5 is negative 3. That one does work.
Check. So
Checkmate.
1 works. All right. Last one.
All right. Okay, last one. This one has 2 radicals. Oh boy, oh boy, oh boy.
Oh, isolate the more complicated.
Yeah, for sure. This is more complicated, so I'm going to get that one by itself. So I need to add this one to the other side. And because those are different on the right, I can't really do anything other than write them next to each other. Okay, the next one is
Scare both sides.
All right, this is scary. But the left side's the easy part, 2x plus 1. The right side, again, we have to FOIL. And
that's going to be 1. Then it's going to be a 1 root x, yep, and then another root x, and then root x times root x is just x.
Right, because it's x squared under the radical.
Yep. And then
So 1.
That's 2 roots of x.
2 of them.
Because they're like radicals like we learned in that other section.
All right. Okay, so we did that, we did that. Now we have to isolate the remaining radical, which is this one. So I'm going to subtract 1 and subtract x first. So on the left, I just get x. These 2 are gone. That's what I have left on the right. And then I'm going to get the 2 out of the way. And then I have to square both sides again. Scare both sides again. I get this. And then squaring this, I get x squared over 4. And then square on a square root, I get just the x. And look at that, I've got a quadratic again.
I know.
Tell me.
Okay, well, we still need to get everything on one side.
All right.
So subtract the x.
So I get x squared over 4 minus x equals 0.
And what I notice is these only, there's only 2 terms. So actually for factoring, we could just do a GCF of x.
Nice, I like that.
So take out that x. That'll leave us with x over 4 minus 1 equals 0. Now set them equal to 0.
X equals 0 is one answer.
Yep.
X over 4 minus 1 equals 0. Add 1. So x over 4 equals 1.
Times by 4.
Multiply by 4. So x equals 4.
And then?
You must check for the phantom. But time is running out here. You guys could do that. You just plug it back in. But I can tell you that in this case, they're both going to work. So why don't you try that right now on your own and see if you can get them both to come out the same. All right. That is it for now, children. We'll see you in class. Ta-ta.